Section 3.6 is about solving quadratic inequalities. Quadratic inequalities, as I should think, must be less than or greater than stuff. So we're going to solve them almost exactly the same way as we solve regular quadratics, except we're going to have a little twist towards the end. It starts by this. The first thing I would think about is how you'd solve y is greater than x squared plus 5x plus 6 by graphing. We'd graph it the same way we'd graph y equals x squared plus 5x plus 6. But because it's a greater than sign without an equal to, then we have to change the line into something that's dotted. When you have a greater than but not equal to, it's dotted, showing that there are not solutions on that parabola, just on one side of it. Now, greater than implies that you're going to fill the parabola in above. You could do this by checking a point up there and seeing that it makes a solution. For instance, if I picked -1, 5, if you put a -1 in for x and a 5 in for y, it would be a true statement. If you put 0, 0 in, you'd see 0 is greater than 0 plus 0 plus 6. 0 is not greater than 6. So you can see that 0, 0 is not shaded in. So graphing, greater than is above, less than is below when it's a y is greater than, a y is less than. And that's true for all equations. And because it's not equal to, we've got to have a dotted parabola. Now, what's also important here is that I want you to understand that there is, this crosses the parabola. It just barely crosses the x-axis in two places. But if we were to zoom in on the x-axis, we would see that it would be shaded in between two numbers where it crosses. That's going to be important in a little bit. If I wanted to graph y is less than or equal to the same exact graph, we would start with the graph again, but this time we'd keep it solid because it's less than or equal to, and then we would graph below it because we can see that less than means below, and all the points that were not working before are going to work now. So how do you graph something, or how do you solve something like this without graphing? Well, we would solve it the same way we'd do normally. We would can use completing the square, which is silly on this problem because we've got an odd number in the middle. We could try to factor it, or we can use the quadratic formula. I see that this one factors real easily, so I would say if it was an equal to sign, I would just say x plus 5 times x minus 2, because those 2 points at -5 and +2 are going to be really important for this problem. In fact, if you think about the way this parabola would look, if it went through the graph, it would be going through the graph, going through the x-axis at -5 and +2. Now, less than, just like when we were graphing, less than is a dotted line, a dotted parabola in this case. But when we're looking at a number line, less than only means that you've got an open circle. So I'm going to put open circles at -5 and +2. And in the number line, I know that this divides the number line into 3 different areas. On the left side, the middle, and the right side. Now, the left side and the right side go together because if there was a parabola going through these 2 points, they would be on the outside of the parabola, right? And if there was a parabola going through it, the inside part, the middle part, would be in the inside of the parabola. So if you can imagine this being shaded with a parabola going through those 2 points, I want to know whether I'm shading on the outside or the inside. So one way of doing this without actually graphing it is to say to yourself, I'm going to pick a convenient point somewhere on this graph. So for instance, I would try a point in the middle. How about 0? Because 0 is so easy. 0 is between -5 and 2. And if I put 0 into the original equation, I get 0 squared plus 3 times 0 minus 10 is less than 0. So, or you could do it in the factored form as well, 0 plus 5 and 0 minus 2. But in either case, -10 is going to be less than 0, which is a true statement. Now, since 0 works and it's on the inside, everything on the inside is going to work. If 0 didn't work, everything on the outsides would work. So what I'm going to have is this shaded in between -5 and +2. Right? Shading in means all the points between -5 and +2, but not including -5 and +2. The way we'd write that out, symbolically would be like this. -5 is less than x, which is less than 2. Or you could use interval notation with -5 and 2 with a comma between them, and parentheses on the outside because they're not included. Or you could say x is greater than -5 and x is less than 2. But it's a lot easier, I think, to say -5 is less than x, which is less than 2. If you keep those numbers in order of their which is greater and which is less, it'll just flow. -5 is on the left and positive 2 is on the right, and they're less than symbols inside there to show that x is greater than -5 and it's less than positive 2. So imagine that it was a parabola through here and I had a y instead of a 0. Y is greater than, if there was a parabola in here, it would be facing up. Greater than means above. So this would be filled in the inside of this parabola, if you could imagine that. I don't know if I have an annotation tool. If I have an annotation tool, I can try to annotate what it would look like. So it would look like something like this. I'm going through that point and filling in above, right? So filling in above is all these points in the middle there. So let's see if I can erase all the ink. All right, let's try another. Oh, okay. So this would be if I was going to graph it, if I was going to put that parabola back in there, it would look something like this. It would be dotted, of course, because it would be less than or just greater than. Y is greater than this thing. Greater than means shade above, and therefore everything between -5 and positive 2 is shaded in. Okay. But you don't really need to know that. It's just another way of looking at it. Okay, so here's another problem. We can try this. You can pause and try it on your own. I think it factors. So pause the video and factor this one and see what the important points are. So I factor it to 2x minus 1 and x minus 6 because the outer terms are -12, the inner terms are -1. They add up to -13. So the first part is going to give me positive 1/2 because 2x minus 1 equals 0. And x minus 6 gives me 6, of course. So I'm going to look at those in the number line again, 1/2 and 6. And I can pick any point. Now I think I picked 1, but you could pick 0 if you want and see what's going on with it. Let's see. I think I'm going to pick a point to test. But why did I put circles that are filled in this time? It's because it's greater than or equal to. Greater than or equal to implies a filled in circle instead of an open circle like the last problem. So I tried a point in the middle, but you don't have to. I tried 1 because I thought it'd be easy to do, but maybe I'll try 0 and also use that one. So if I put an 1 in for x in the factored form or in the other form, 2 times 1 minus 1 and 1 minus 6, so I get what? Negative 1 times, or 1 times -5, which is -5. -5 is greater than 0 is a false statement. That tells me that nothing in the inside is going to be filled in. Now, maybe it would have been easier if I had just done what happens when x is 0. X is 0 is on the outside. If you put a 0 in here, you'd get 6 is greater than or equal to 0. Now, if the outside works, then everything on the outside will work. So maybe that would have been easier. But either way, the inside doesn't work and the outside does work. If you picked a number like 7, it would be a true statement if you plugged it in for x. So the way this is going to work is that the outsides will both be filled in. And when I have a statement of what it looks like, it's going to be a compound statement. It's going to say x is less than 1/2, less than or equal to 1/2, or x is greater than or equal to 6. Both sections work. And just again, if you can imagine what that looks like, I don't know what I'm doing. All right, if you look and see what it looks like, if you put a parabola through there, you'd have a solid parabola this time. And if this was y, it'd be y is less than. Y is less than means shade below. And notice that when we shade below, that the part over here and the part over here gets filled in. And that's why it's on the outside this time instead of the inside. All right. All right. So last problem here does not factor. So what I'd like you to do is I'd like you to pause and try the quadratic formula on this to figure out where the points on the number line are that are going to be true for this statement if it was equal to 0. Go ahead and pause for a second. And I hope you try the quadratic formula. I did like this. The opposite of b is plus or minus b squared minus 4 times 3 times negative 9 all over 2 times 3. And negative 4 times 3 times negative 9 is an addition problem because you have negative 4 times negative 9. So we have 4 plus 108, and that's 112. And 16 goes into 112 7 times. So you can simplify a little bit further. Negative 2 plus and minus 4 radical 7 all over 6. And since 2, 4, and 6 are all divisible by 2, you can go a little bit further. And it's 1 plus and minus 2 squared of 7 over 3. Now, if you didn't get that, try it from here. Put those two numbers on the number line, 1 plus that and 1 minus that, where they are relative to one another, and where's another point that you know. If it's 0, that's great. If it's not 0, pick another point that will be a true statement or a false statement. So negative 1 plus and minus 2 radical 7, what I did was I said, well, negative 1 minus 2 radical 7 over 3 is to the left of 1 plus 2 radical 7 over 3, because one's subtracting that and one's adding it. So, and I put open circles at those 2 points because it's not equal to those 2 points. It looked to me like 1 minus 2 radical 7 over 3 would be a negative number, because 1 minus a negative number, 1 minus 2 something is going to be negative over a positive. So I know the one on the left is negative, and the one on the right is negative 1 plus 2 radical 7. 2 radical 7 is bigger than 1 because 2 is bigger than 1. So this one must be a positive number on the right side. So I surmise that 0 must be somewhere in the middle. And 0 is easy because when you plug 0 into the original equation, you get 3 times 0 plus 2 times 0 minus 9. Negative 9 is less than 0, which is a true statement. If 0 is a true statement, then everything on the inside must be true. So I filled in between the two holes, and I'm going to write my statement as the one on the left is less than x, which is less than the one on the right. And that's how we solve quadratic inequalities. Sometimes factoring, sometimes quadratic formula. I find the number line to be very convenient for being able to figure out whether it's inside or outside, but it's never just the left or just the right. It's either the inside or the outside. So there it is.